In the decades following World War II, Japan experienced one of the most explosive economic booms in human history. Cities expanded, industries multiplied, and international travel surged at an unprecedented rate. Among these rapidly growing urban centers was Osaka, a commercial powerhouse that pulsed with energy, ambition, and relentless activity. But beneath that growth was a quiet, growing crisis. Air travel, once a luxury, had become essential. Businesses depended on it. Tourism thrived on it. The existing airport serving Osaka Itami Airport was struggling to cope. Originally built for a different era, it was now overwhelmed by the sheer volume of flights. Planes landed and took off in tight schedules, squeezing into limited runway capacity. Delays became routine. Expansion was discussed. But there was a problem. There was nowhere to expand. Osaka, like much of Japan, is geographically constrained. Mountains consume a significant portion of the land, leaving only narrow plains for cities to exist. Every available piece of flat land had already been claimed by homes, factories, roads, and infrastructure. To expand the airport would mean demolishing entire communities, displacing thousands of people, and igniting public outrage. And then there was the noise. Jet engines roared over residential neighborhoods day and night. Families complained. Schools were disrupted. Hospitals struggled with the constant thunder overhead. Lawsuits began piling up. Residents demanded action. Eventually, strict curfews were imposed, limiting flight operations during nighttime hours, further reducing the airport's capacity. Japan was facing a dilemma that seemed impossible to solve. They needed a bigger airport. They had no land to build it on, and the public would not tolerate expansion where they lived. For a while, the government explored conventional options, relocating the airport farther inland, building smaller regional hubs, or even limiting air traffic growth. But none of these solutions matched the scale of Japan's ambitions. The country wasn't just trying to keep up. It wanted to lead the world. So engineers, planners, and visionaries began to think differently. If land was the problem, perhaps land didn't need to exist already. Perhaps it could be created. It was an idea that sounded almost absurd at first, building an airport not on land but in the sea, far away from residential areas, free from noise complaints, with unlimited space for expansion. But this wasn't just any stretch of water. The ocean is unpredictable, powerful, and unforgiving. Waves crash, storms rage, and beneath the surface lies unstable terrain that shifts and settles over time. Still, Japan had built its identity on defying limits. From bullet trains to earthquake-resistant skyscrapers, the country had repeatedly proven that engineering could overcome nature, at least to some extent. And so, what began as a desperate idea slowly transformed into a bold national vision. They would build an airport in the ocean, not floating on water like a ship, but standing firmly on an artificial island, created entirely by human hands. It would be one of the most ambitious construction projects ever attempted. And it would come with risks no one could fully predict.
Turning the idea of an ocean airport into reality required more than ambition, it required belief. Not just from engineers, but from politicians, investors, and the public. The cost alone was staggering. Billions of dollars would be needed before a single plane could land. Critics were quick to speak out. They called the project wasteful, dangerous, unrealistic. Some argued that the ocean would eventually reclaim whatever was built. Others warned that the soft seabed would never support such a massive structure. There were fears of catastrophic failure, of runways cracking, buildings tilting, or the entire island slowly disappearing beneath the waves. But supporters saw something else. They saw opportunity. An airport in the sea would eliminate noise pollution over cities. Flights could operate 24 hours a day without disturbing residents. It would become a global hub, connecting Japan to the world with unmatched efficiency. And perhaps most importantly, It would showcase Japan's technological prowess on a global stage. After years of debate, planning, and feasibility studies, the decision was made. The project was approved. The next challenge was choosing the exact location. After careful evaluation, engineers selected a site in Osaka Bay. It offered the perfect balance, close enough to the city for convenience, yet far enough to avoid noise issues. The water depth was manageable. Shipping lanes could be adjusted. On the surface, it seemed ideal. But what lay beneath the water told a different story. When engineers began analyzing the seabed, they discovered thick layers of soft marine clay, stretching deep below the ocean floor. This wasn't solid ground. It was unstable, compressible, and filled with water. Building on it would be like placing a massive structure on top of a soaked sponge. The implications were clear and unavoidable. The island would sink. Not suddenly, not catastrophically, but slowly, continuously, and inevitably. The question was no longer whether it would sink. The question became, could they control the sinking? Instead of abandoning the project, engineers chose to confront the problem directly. They began developing strategies not to eliminate sinking entirely, but to predict it, manage it, and design around it. This shift in thinking was crucial. Rather than forcing nature to obey, they would work with it. They calculated how much the ground might compress over decades. They estimated how quickly water would escape from the clay under pressure. They modeled scenarios, ran simulations, and tested solutions never before attempted at this scale. At the same time, the design of the airport itself began to evolve. It wouldn't be a rigid, unchanging structure. It would be flexible, adaptive, capable of adjusting as the ground beneath it shifted. This was no longer just a construction project. It was an ongoing experiment in engineering, one that would continue long after the airport opened. With plans finalized and risks accepted, Japan prepared to begin. The ocean, calm and silent, awaited the first move.
Construction began with a problem that couldn't be seen, but would define everything that followed. The seabed. Beneath the surface of Osaka Bay lay layers of clay deposited over thousands of years. These layers were soft, waterlogged, and highly compressible. Under normal conditions, they remained stable. But once massive weight was added, everything would change. Imagine pressing down on a wet sponge. Water slowly squeezes out. The sponge shrinks. The shape changes. That is exactly what would happen beneath the artificial island. To prepare for this, engineers needed to accelerate a process that would naturally take decades. If they simply dumped soil into the sea and built on top of it, the ground would continue settling for years, causing unpredictable and uneven sinking. So they came up with a solution that was both simple and ingenious. Sand drains. Thousands upon thousands, eventually over 1 million vertical drains, were driven deep into the seabed. These drains acted like channels, allowing water trapped within the clay to escape more quickly when pressure was applied. By speeding up the removal of water, the soil would compress faster. Before the airport was fully built, it was like pre-squeezing the sponge. But installing these drains in the open sea was no easy task. Specialized equipment was used to drive them deep into the ocean floor with precision. Each one had to reach the correct depth. Each one had to function properly. Any mistake could lead to uneven settling later. While this was happening below, another massive operation began above. The construction of the seawall. This wasn't just a barrier, it was a fortress. Massive concrete blocks, some weighing several tons, were transported and carefully placed to form a ring around the Budushi Island. Waves crashed against them. Currents shifted around them. But slowly, steadily, a boundary took shape. Inside that boundary, the ocean would be transformed. Once the seawall was complete, the real spectacle began. Ships arrived in endless waves, carrying rock, sand, and soil from distant locations. They dumped their loads into the enclosed area day after day, night after night. The water level began to rise, not because the sea was rising, but because the land was forming beneath it. First, nothing was visible, just murky water. Then, gradually, the surface broke. A patch of land emerged. Then it grew, and grew, until what was once open ocean became a vast artificial island. But as the island rose, something else was happening. It was sinking at the same time. The weight of millions of tons of material pressed down on the clay below, forcing water out through the sand drains. The ground compressed. The island settled. Measurements were taken constantly, and the data revealed a troubling trend. The sinking was faster than expected. Engineers watched closely. Adjustments were made. More material was added in certain areas to compensate. But the reality was clear. This project would not follow a straight path. It would be a constant balancing act between construction and correction, between progress and adaptation. The island was alive in a sense, moving, shifting, responding to every decision made above it. And this was only the beginning. By the time construction reached its next phase, the dream of building an airport in the sea was no longer just an idea on paper. It had become something far more dangerous, a commitment. There was no turning back now. Too much money had been invested. Too much reputation was at stake. Japan had stepped into a battle not against another nation but against nature itself. And nature does not negotiate. The chosen site in Osaka Bay appeared calm on the surface. Gentle waves rolled across the water. The horizon stretched peacefully into the distance. But this calm was deceptive. Beneath it lay shifting currents, unpredictable weather patterns, and a seabed that refused to stay still. To build an island here, engineers first had to claim territory from the ocean. The strategy began with something deceptively simple: build a wall. But not just any wall. A massive circular seawall, designed to hold back the ocean itself. Construction crews brought in enormous concrete blocks, each weighing several tons. These weren't ordinary building materials. They were engineered to withstand constant wave impact, saltwater corrosion, and the force of storms that could rise without warning. Ships transported these blocks one by one to the construction site. Giant cranes lifted them into position, lowering them slowly into the sea. Divers and underwater crews worked in dangerous conditions, guiding placement with precision. Every block had to fit perfectly. Every gap had to be sealed, because if the seawall failed, even slightly, the ocean would rush in and undo everything. Unlike construction on land, nothing here was stable. The waves never stopped moving. The wind constantly shifted. The seabed itself was slowly settling beneath the growing weight. This meant that even placing a single block required extreme coordination. Engineers had to calculate wave timing, water depth, and seabed conditions in real time. A small misalignment could weaken the entire structure. At times, progress slowed to a crawl. At other moments, storms forced crews to stop completely. But delays were not an option. Every extra day increased costs. Every setback added pressure. And yet, rushing could lead to catastrophic failure. So they continued slowly, carefully, relentlessly. As the seawall began to take shape, the ocean responded. Waves crashed harder against the growing structure. Currents shifted unpredictably. Typhoons loomed on the horizon, threatening to tear apart months of progress in a single night. Workers found themselves battling not just physical exhaustion, but psychological strain. The scale of the project was overwhelming. Standing on temporary platforms surrounded by endless water, they were constantly reminded of how small they were compared to the forces around them. And yet, piece by piece, the wall grew. After months of continuous effort, the seawall began to form a complete ring. What was once open ocean was now partially enclosed. a controlled space carved out of chaos. This moment was critical, because once the circle was complete, everything would change. Inside the wall, the water would become calmer. Waves would lose their power. For the first time, engineers would have a controlled environment in which to begin building land. But completing the ring was also risky. If any section was weak, the pressure of the ocean from outside could exploit it. Engineers conducted constant inspections, reinforcing vulnerable areas, ensuring that the structure could hold. Finally, the last gap was sealed. The circle was complete. For the first time, humans had drawn a boundary in the sea, and the sea had been forced to respect it. Inside the seawall, the transformation was immediate. The chaotic motion of the ocean gave way to a strange stillness. The water became calmer, almost unnaturally so. It was as if a piece of the ocean had been frozen in place. This stillness was not just visual, it was strategic. Calm water meant controlled construction. It meant materials could be deposited more accurately. It meant machines could operate more efficiently. It meant progress could accelerate. But it also marked the beginning of something irreversible. Because now the real work would begin. With the ocean contained, fleets of ships began arriving, each carrying massive loads of rock, sand, and soil. They came from quarries, mountains, and distant locations across Japan. Entire landscapes were being reshaped to feed this project. Hills were cut down. Earth was transported across vast distances. All of it destined for one place, the center of the seawall. Day after day, ships dumped their loads into the enclosed water. At first, the materials disappeared beneath the surface, swallowed by the sea. But gradually, something began to change. The water level inside the wall started to rise. Not because the sea was rising, but because the ground beneath it was growing. Weeks turned into months. And then, one day it happened. A small patch of land broke through the surface. It was muddy, uneven, and unstable, but it was real. For the first time, what had once been ocean was now solid ground. Workers stood and watched as this new land expanded. More material was added. The surface grew wider, higher, stronger. The island was no longer just a concept. It was becoming a physical reality. But even as it rose above the water, it was sinking below. Every ton of material added to the island increased the pressure on the seabed below. The soft clay, already weakened by water, began to compress more rapidly. Water was forced out through the sand drains installed earlier. The island settled, then settled again, and again. Measurements revealed a troubling truth. The more they built, the more the island sank. It was a paradox. To create land, they had to add weight. But adding weight caused the land to sink. Engineers found themselves in a delicate balancing act. Adding enough material to raise the island above sea level, while accounting for the inevitable sinking below it. Unlike traditional projects, this was not a static build. The island was constantly changing. Levels had to be remeasured daily. Adjustments were made continuously. Plans were revised in real time. What was true yesterday might not be true today. It was as if the ground itself had become a living entity, responding to every action taken above it. And this forced engineers to adopt a new mindset. They were not building on the land. They were building with it. By the end of this phase, the impossible had begun to take shape. A massive artificial island now stood in the middle of Osaka Bay, surrounded by a fortress-like seawall, rising from the ocean through sheer human effort. But it was not stable. Not yet. The real challenge was still ahead. Because building the island was only half the battle. Now they had to build an airport on top of it, on land that was still sinking. By the time the artificial island stood above the waters of Osaka Bay, the world had already begun to take notice. What Japan was attempting was unlike anything ever done before, not just in scale but in complexity. They had built land where none existed. But beneath that achievement lay a quiet, persistent truth. The island was still sinking, and it wasn't slowing down. Unlike storms or waves, the real threat could not be seen. It existed deep beneath the surface, within the layers of soft marine clay that continued to compress under unimaginable weight. Every truckload of soil, every slab of concrete, every piece of infrastructure added pressure. And the ground responded the only way it could, by sinking. At first, engineers believed they could predict and control this movement with precision. Their models had estimated how much the island would settle over time. They had accounted for years, even decades, of gradual compression. But reality proved more stubborn. The sinking was faster, deeper, more relentless than expected. This was no longer just a construction challenge. It was a test of whether human calculation could truly match the complexity of nature. Instead of retreating, Japan did something extraordinary. They adapted. Engineers returned to the core problem, the seabed, and focused on accelerating a process that normally takes generations. The sand drains installed earlier now became the heart of their strategy. These vertical channels allowed water trapped inside the clay to escape more quickly. As water drained out, the soil compressed faster, stabilizing the ground sooner than it naturally would. It was a bold idea. Force the sinking to happen early so it wouldn't happen later. But even this solution had limits. The clay layers were deeper than anticipated. Some sections compressed unevenly. And as construction continued, new weight kept being added, pushing the system further. So the strategy evolved again. If the ground could not be made perfectly stable, then the structures above it would have to adapt. This realization changed everything. Instead of rigid construction, engineers designed systems that could move, adjust, and survive change. Buildings were equipped with adjustable supports. Sections could be lifted using hydraulic jacks. Runways were designed with extra height to account for future sinking. This was no longer traditional engineering. This was adaptive engineering, a philosophy built on the idea that some forces cannot be stopped, only managed. If the ground could not be made perfectly stable, then the structures above it would have to adapt. This realization changed everything. Instead of rigid construction, engineers designed systems that could move, adjust, and survive change. Buildings were equipped with adjustable supports. Sections could be lifted using hydraulic jacks. Runways were designed with extra height to account for future sinking. This was no longer traditional engineering. This was adaptive engineering, a philosophy built on the idea that some forces cannot be stopped, only managed. With the island stabilized as much as possible, construction of the airport began. Runways stretched across the reclaimed land, long, straight, and precise. Terminal structures rose, combining beauty with resilience. Every beam, every column, every foundation was designed with one thought in mind: this ground will move. Build anyway. When Kansai International Airport finally opened in 1994, it was hailed as a miracle. Planes landed smoothly. Passengers moved through the terminal. Operations ran efficiently. From the outside, it looked perfect. But beneath it, the island continued its slow descent. Years passed, and the predictions became reality. The airport sank meter by meter. Engineers monitored every change. Instruments tracked ground levels with extreme precision. When sections dropped too low, adjustments were made. Buildings were lifted. Barriers were raised. Reinforcements were added. This was not a one-time fix. It was a continuous effort, a partnership between humans and the forces they could never fully control. And yet, despite everything, the airport never failed. Flights continued. Passengers arrived. The system held. What Japan built was more than an airport. It was a statement, a demonstration that even in the face of overwhelming natural limitations, progress is possible, not through domination, but through understanding. The project revealed something deeper about engineering. Perfection is not always achievable. Stability is not always permanent. And success does not always mean eliminating risk. Sometimes, success means learning how to live with it. Today, Kansai International Airport still stands, still operating, still sinking, still adapting. It has become a symbol studied by engineers around the world. a lesson in ambition, risk, and resilience. A reminder that innovation often comes with consequences that cannot be fully predicted. And yet, despite those consequences, it remains one of the most remarkable achievements of modern engineering. In the end, the story is not about an airport. It is about a question humanity continues to ask. How far can we go? Japan answered that question not with words, but with action. They built land in the ocean. They constructed an airport on unstable ground. They faced a problem that could not be solved and solved it anyway, not by stopping the sinking, but by rising above it. Barriers were raised. Reinforcements were added. This was not a one-time fix. It was a continuous effort, a partnership between humans and the forces they could never fully control. And yet, despite everything, the airport never failed. Flights continued. Passengers arrived. The system held. What Japan built was more than an airport. It was a statement, a demonstration that even in the face of overwhelming natural limitations, progress is possible, not through domination, but through understanding. The project revealed something deeper about engineering. Perfection is not always achievable. Stability is not always permanent. And success does not always mean eliminating risk. Sometimes, success means learning how to live with it. Today, Kansai International Airport still stands, still operating, still sinking, still adapting. It has become a symbol studied by engineers around the world. A lesson in ambition, risk, and resilience. A reminder that innovation often comes with consequences that cannot be fully predicted. And yet, despite those consequences, it remains one of the most remarkable achievements of modern engineering. In the end, the story is not about an airport. It is about a question humanity continues to ask. How far can we go? Japan answered that question not with words, but with action. They built land in the ocean. They constructed an airport on unstable ground. They faced a problem that could not be solved and solved it anyway, not by stopping the sinking, but by rising above it.